Alright, so now we're going to move on to one of my favorite topics in ARM assembly, or in any assembly, or any programming language for that matter, which is if-else statements and conditionals. So for those of you coming from a high-level language background, I know I say this a lot, but it's important that I say it because there's a lot of analogies between the high-level languages and this low-level language. So from high-level languages, you might be familiar with if statements and else statements, and then booleans, and then iterative loops such as for loops and while loops, and using those to solve problems. Like those make up particular algorithms. Well, that's exactly what we're going to be doing the equivalent of in assembly in this video. So I'm really excited because this is probably one of my favorite topics. So if you guys are excited too, then enjoy the video. So first things first, go ahead and delete all of that stuff that we were working on with the mod from the last video, but keep all the stack commands that we were using. If you haven't seen the video on the stack, be sure to watch that. The link is in the description, because that's where we explain what we had to do to get rid of that segmentation fault. So now the code is working normally, but now we no longer have a need to work with mod because we covered the basics of assembly already, so now we just need to clean that up and start over so that we can move on to some more advanced code. So over here what I'm going to do is I'm going to add a comment and I'm going to talk about what we're going to do. So we're going to be working with conditionals, which is the same thing as if-else. And particularly the task that I'm going to have you guys do is we're going to do a very basic printing task. So we're going to we're going to do kind of, if you guys remember from a previous video, we were writing a print statement about Alfredo pasta. So I'm going to go ahead and keep that food theme. So the first print statement, so I'm going to say print statement 1, and we're going to reuse that print statement. So Alfredo pasta is the best dish in the world. And we're going to have 3 print statements. So the second print statement, so print statement 2, again, we're going to stick with the food theme here. So we're going to say the best flavor of cake is cookies and cream. Put an exclamation. And then the last print statement, we're going to have print statement 3 is, I'm thinking of all of this on the spot, by the way, so that's why it's taking some time, but I'd say let's go with, by the way, the reason I came up with the cake statement is because today is actually my brother's birthday. So the final print statement we're going to say is best fast food place of all time is In-N-Out. All very true statements. If you disagree with me, you're wrong. I'm just kidding. Okay, so that's the first thing we're going to do. So the goal is we're going to have the user enter a number. So user enters a number, 1, 2, or 3. And 1 corresponds to print statement 1. 2 corresponds to print statement 2. And of course 3 corresponds to print statement 3. And if the user enters anything that's not any 1, 2, or 3, if it's any other input, like it could be something like this, if it contains 1, 2, or 3, but it's not exactly 1, 2, or 3, you know, it doesn't count. So else, we're going to, in this case, we'd need to add a 4th print statement for, which is oops, enter a valid input, please. Okay, so that's our very simple task that we're going to do, and it gives us a chance to experiment with the concept of if-else statements, but in assembly. So it's not, there is no actual keyword called if and else in assembly, so we're going to have to work with registers to represent the idea. So that's what we're going to be doing right now. So the first assembly keyword that we need to know is the compare keyword. So this is going to come in super handy when we're working with conditionals. So compare, it's CMP. And when we compare, we're comparing the values in registers, or the value in a register with a particular numeric value. So what we need to do is we need to compare, and let's pick a register. So I'm going to pick a register 5. We're going to have to set up register 5, which is going to be the user input. But for now, I'm just introducing you guys to the comparison keyword. So we're going to compare the value in register 5 with, we're going to compare it with the value 1. And if it's equal to 1, then we know to print the first statement. And if it's equal to 2, we know to print the second statement. 3, third statement. Anything else, fourth statement. So that's where the comparison comes in handy. So this is basically how you create an if-else statement the way you would in Java or C++. Using CMP is how you would do it, and another word called branch. Those two are what you'd use to represent the idea of an if-else statement. So we're going to say BEQ, which stands for branch equal to, meaning you're comparing the values in register 5 with the value 1, or the value in register 5 with 1. If the value in register 5 is equal to 1, that is what BEQ stands for. So if the value in register 5 is equal to 1, then we branch to some other label. So we're going to have to create a label. So let's call that first print statement. All right, you know what? Let's keep it simple. First print. And then we need to check if the value is 2. So CMP R5 2. If the value of the user input is equal to 2, then we need to print the second statement. So BEQ, branch and equal to, second print. Again, we have not created these labels yet. We need to do that. But I'm showing you guys how the concept of an if-else statement works in assembly, because there is no such thing as an if and an else. And then we need to do the same thing, but for 3. BEQ, if the value in register 5 is equal to 3, then branch to another label, which we're going to call third print. And then we need to actually create these labels. Oh wait, we forgot about the else. Actually, you know what? We'll deal with else later. So we need to create these labels. So first print, second print. For now, we're just giving the user the benefit of the doubt and assume they entered a valid input. And hence we're going to move to either of these 3 labels. And if not, that's another case that we're going to handle later in this video. So first print, second print, third print. And so what we have to do here in the first print, let's go ahead and move this comment over here. Okay, so what we have to do, the same way we've been working with print statements, we're going to load into register 0, and we need a label for this print statement. So we're going to say print s1, and then bl printf to call the printf function to print that. And then we need to do the same thing for this one, for the second print statement. So load into register 0, print S2. Again, we have not created this, but let's call the printf function. And lastly, well, not lastly, because we are not working with the else case right now. And then LDR R0, print S3, and then BL printf. So we took care of the very basic case right here. So assuming the user entered any one of those three numbers, it's going to go to its respective label. And so now the next part we have to do is we have to actually create the print statement labels. So print S1 dot ASCII Z, and we're going to just copy that, paste that in there, and I'm just going to add a \n for new line to keep it clean. You should probably do the same. So print S2 dot ASCII Z, and the cake one, definitely the best flavor of cake in the world, and then print S3 dot ASCII Z. Nothing compares to In-N-Out burgers. Okay, so we got our labels, and in each of these labels it would print the respective print statement. Now, we actually did not take care of the first step, which is to actually set up register 5, which is what we're using for the user input. So when it comes to user input, what do we use? That's right, scanf. So we need to first load into register 0, and we're just going to say input, and then BL scanf. And then we didn't work with, we didn't create our input, so input. Alright, so just make sure you add the \n to all these print statements, and then for the input, make sure it's %d so that it indicates that it's taking in a decimal value or an integer. So the next thing we have to do is, like I mentioned, we're treating register 5 as the register with the user input. So, but notice what we did here is we put the input into register 0, and then scanf returned its value in register 0 because scanf is a function. So to get that into register 5, we just have to simply say move into register 5 the value in register 0. So now what this does is it moves the user input into R5. So that's how we can use R5 accordingly. Okay, so we got that taken care of. And now the next thing is we need to take care of the else. So we made these comparison statements for 1, 2, and 3. And we did not take care of a condition whether it's not 1, 2, or 3. So what I'm going to do here is underneath each comparison, so if it's equal to, we take it to first print. If it's not equal to, so BNE, then what we do is we take it to, we're going to create a label here called other. And then this is going to be other, where we're making these comparison statements. And you'll see why I'm doing this in a second. So within other, we're going to compare with register 5 with 2. If it's equal, then we take it to the second print label. And if it's not, we take it to other 2. And this is going to be other 2 right here, where we compare the value with 3. If it's equal to 3, we take it to the third print label, and if not, we say error, or let's not call it error, let's call it invalid input. And then here we have to create invalid inputs where we need the print statement LDR register 0 equals invalid. We can call it what we want. I'll just call it invalid, and BL printf takes that as an argument and it prints the invalid input. So we didn't actually create that fourth print statement label, so print s4 dot ASCII z, and then where is it? Here. Oops, enter a valid input, please. So let's do that, and then \n. Okay, so why did I create these other labels, or these labels called other? Because, like, you might think, oh, you could have just done all these comparisons, 1, 2, and 3, and then at the very end you could have just said, oh, if it's not equal to, then just take it to invalid input. It doesn't actually work that way. Why? Because the last comparison I was making was register 5 and 3. So if it was not equal to 3, then it would immediately take it to invalid input. But what if it was 1 or 2? Then it would take it to invalid input, even though 1 or 2 is a valid input. So when we're dealing with the branching, or the conditional branching, it always looks at the very last CMP, or the most recent CMP instruction that was called or used. So when we do that at the very last part, the most recent comparison was with R5 and 3. So the moment it's not equal to 3, it immediately considers it invalid, even if it's 1 or 2. So that's why we have to do a comparison, or 3 different BNE instructions for each comparison, so that it actually compares it while taking into account that there's 3 valid inputs. I went ahead and moved the task directions to the top of the code, just so it's more organized. And now the last thing I want to do before we actually test this code is I want to add more comments, so that, like pseudocode comments, so that for someone on the outside it's easier to read this code. And this is a habit that all programmers should be keeping and maintaining. And as a matter of fact, for assembly, it's probably a better habit to start by writing all the comments, like all the pseudocode in comments, before actually writing the assembly instructions themselves. I went the other way around, but that's just because I got a little excited because I really like this topic. But, that's not something you should be doing on a regular basis. You should be writing all the comments first and then writing the actual assembly instructions, like CMP, BEQ. First write that we're going to compare the user input with this value, and if it's equal, we're going to take it to this label. If not, we're going to do something else. So you have to write that in comments, in either in English or in pseudocode, preferably both, before writing CMP, BEQ, BNE, if you know what I mean. So, but I got excited, so we're going to have to do it the other way around. Okay, so next, we're going to first say user input. Sorry, I'm too excited. We're going out of order here. So we already took care of here, user input. So take user input. That's the first thing. Should be an integer. And then we're going to compare user input with 1. If input is 1, we're going to print the first statement. Print first statement. Else, this is basically equivalent to the else, like if input equals 1, print this. Else, if input equals 2. So that's that first else in the, like as you might see in a C or Java code. So Let's go ahead and say else. If input is not 1, go to other to find other potential valid inputs. So here is we're going to say user input equal or compare user input with 2. And then if it's equal to, so if input is 2, we already verified that it's not 1, because that's the first thing that was compared. Then print second statement. And then we have one more chance for a valid input, which is 3. So else, if input is not 2, go to other 2 to find last potential valid input. And that is where we compare user input with 3. And if it's if input is 3, and we already verified, because we took care of the comparing with 1 and the comparing with 2 already, because they came first in terms of the order of this code, so we already verified that it's not 1 or 2. Print third statement. And then we are else, if it's not 3 and we already know it's not 1 or 2 either, then we know the input's just invalid. Else input is invalid and must direct or must notify user. And in the invalid input label, user entered an invalid input, so we must tell them. And that's exactly what happens here. All right, and then we took care of these print statement comments already. And then our stack comments at the bottom and the top, of course. Okay, so it looks like this code is good to go for testing. Okay, so just make sure you save. So let's see, let's go ahead and compile. Again, the executable is called test. And one thing I want to point out is that in the previous videos, test was our executable for main.s and mod.s. You don't have to create a different executable if you're using a different combination of files, or if you're, like in this case, we're just using main.s. You don't have to create a whole different executable name. You can call it the same name, and the same executable file, which we called test, that is going to modify itself because it's only one file that's being compiled this time. So let's go ahead and compile. And then we are going to run test. And notice that nothing actually happened because we didn't actually print anything prior to the user entering an input. So if we entered something like 2, for example, you'll notice that every print statement printed. Now, why is that? So let me go ahead and show you guys in the code. We're having this error is because regardless of what label the program should be directed to when we enter a particular user input, we don't have anything to skip these labels. So let's say we put in 1, it would print the first statement, but we don't have anything to prevent it from skipping these other these other labels. Sorry, and because the program just goes in order of instructions. It's just going to go to the second label regardless of whether this first print statement happened, or sorry, this, like, regardless of whether we entered one, if we did, like, it's going to print the statement, and regardless of whether or not it was 1, it's still going to, or it still wasn't 2, but regardless, it's going to go to the second label right here. And then it's going to go to the third label, even though we already took care of our intended task because the input was 1. So we need to figure out how do we skip over these labels. So what we have to do is we need to do, we need to create another branching statement that skips to a different label. And we're going to call that label game over. And then we're just going to put all the stack commands here within this label. So if we branch to this game over label, it'll skip over the other labels, and it's going to immediately come here to game over. So we actually need a label in this case if we want to skip over our particular conditional labels. Okay, so for each label, we need to do a branch. So b game over. Now what this does, so notice how we've been doing BL and then these comparison statements BEQ, BNE. So the B is for branch. So when we're working with the conditionals here, BEQ means branch if equal to. Like if the two things you're comparing are equal to each other, then you branch to that label. And then NE is for not equal to, meaning the two things you're comparing, if they're not equal to each other, then you go to that label. But for this just plain B without anything after that, and BL is for branch and link, so it takes the function and it takes its return value and puts it into register 0. So that's BL. But what about just B? So B is for branch, meaning nothing, no conditions, no register math or anything like that. Just straight go to that label. So in this case, B for branch is what we need. So when we first print, we print the statement and it's over. That's all we had to do because the input was 1. We handled it accordingly, game over. So we just straight go to the game over label. And that's why we needed a label. In the label, we just took care of our closing stack instructions, or the game over label. So we have to do the same thing for these other labels. So in the second print, say they entered 2. We handled it accordingly. Game is over. We don't do anything else. Same thing here. B, game over. And then, of course, in the invalid input, we have to do the same thing. It's game over. As soon as we handle the input accordingly by printing the corresponding statements, there is nothing else to be done except for the closing stack instructions. So we basically have to straight go there without any conditions preventing us from doing so or anything like that. So that's what B is. So before we test this code, let me just tell you guys. Let me just write in the comments. Again, this whole video I've been going the other way around, writing the instructions before the comments, which should be comments before instructions. So we need to, game over, print or input handled accordingly. So I'm just going to copy that comment for all of the times that we called B game over. Okay. And the last thing I want to do, just for conceptual understanding, I want to tell you guys about the different branches. So B is for branch, no conditions. BL, branch and link, which is what we use when we want to call functions. B equal to, branch to label if equal to. B not equal to, branch to label if not equal to. Sorry. And then there's a few more things. There's a few more different types of branches that just weren't, or conditional branching, that just weren't applicable in this problem, but you'll probably need for other problems. So there's BGE, which is branch to label if greater than or equal to. And these are just different comparisons. So if the two things you're comparing, if one of them is, or if the first argument is, or if the first thing you're comparing is greater than or equal to the second thing, then That's what BGE means. And then similarly, BLE is branch to label if less than or equal to. So if you're comparing register 5 with 0, for example, if the value in register 5, the first thing you're comparing, is greater than or equal to 0, then that's BGE. If it's less than or equal to 0, it's BLE. And if it's equal to, then if you just wanted to take care of whether it's equal to 0, then it's just BEQ, like we've already been working with. And then BGT is just greater than, so not greater than, equal to. So branch to label if greater than, or just greater than. So if register 5 is equal to 0, then it's not going to count. If you're using BGT, then it will branch to the label if register 5 or whatever register you're using is greater than the value you're comparing. And of course, BLT, branch to label if less than. So if the first thing you're comparing is less than, the second value, that then it will direct you to that particular label. If not, if it's equal to 0, if it's greater than 0, then it won't count. So that's just a bit about all the different branches. So B for regular branch, meaning just shoot straight to it no matter what. And then branch and link for functions, and then all of these are conditional branches right here. Now there's one final thing that I did off camera, which is I just cleaned up the code a little bit. I put the input here, which was already there. I showed that to you guys on camera, but what I did was I did this .balign 4, and then I gave a label called number, and then .word 0. So if you guys don't know what this means, it's just .word is basically indicating that what we want is 4 bytes, because a word would take up 4 bytes of memory, and an integer takes up 4 bytes. So this number would basically be our the actual integer value of the user input. So if I show you guys here, I wrote the C equivalent. So like when you call scanf in C, you have this %d as the first argument, and then you have the address of a variable as the second argument. This is basically all we're doing. So in the first register, we load the address of input, which is this %d, and then we actually need an integer, which is our .word, and I called it number here in line 13. So that's what I did, and I loaded that, and I put that into register 1, because it goes in order of registers for arguments. And then what I did was, after calling scanf, we want to make sure that we're ultimately storing the user input into register 5, because that's the register we use for the remaining logic in our code. So we have to, what I did was scanf has saved the input at the location pointed by number, because this address, this and sign in C, refers to address. So into register 5, I just load the address of number. And then I load, in these square brackets mean the content, so I load the content that's in register 5. So this is a very common thing in assembly programming. We first load the address into a register. Once we have the address, we take the content that's currently in that address, and then we put that into the particular register. That way the register has that integer value in this example. So like, think of it like a home address. So a home address at some point in time can have one person living there, and then another point in time maybe like a different person living there, or more than one person living there. So the people who are living in this house don't indicate, or it doesn't identify the house, it's the address that identifies the house. Similarly, we're just loading the address, and whatever content or whatever people in the house that is pointed by that address number, that content is being stored into register 5. So once we do that, then register 5 finally has the content. So I debugged this off camera, and I found that another reason why the code wasn't working was because register 5 didn't actually have the correct user input. So it was always becoming 1, and which isn't right even when we put 2 or 3 or anything else. So that's why. So I had to just fix this off camera, and this is basically all that happened. Rest looks good. Again, just make sure that within your print statements you're immediately branching to game over. And then, yeah, the rest should be good. Okay, so again, make sure you save and then compile the code, and then ./test, and then enter a number. So this time it's actually printing. And then what we do is we put in a number. So let's just go with 3. And it did print the third print statement, which, if you guys remember, it's the in and out statement. And then let's run it again. Let's do it for every input. So if we put 2, you talked about the cake. There we go. Enter 1, Alfredo pasta. And then we don't have to put 4. We can put any input that's not 1, 2, or 3, but let's just go with 4. Oops, enter a valid input, please. Again, let's put in a non-integer. Let's go with A. Oops, enter a valid input, please. And then one more. Let's just go with something random. All right, so the code works, and that is conditionals. So basically, the logic of the conditionals that we had was pretty much correct. It's just the reason why the code wasn't working at first is because we incorrectly set up the user input to be stored into register 5. So like we had to do all that loading address, loading content, and then take that saved value, or take that value and then save it into register 5 from register 0, so that we could use that as our comparison point for the values 1, 2, and 3 to decide which statement to print, and if it isn't 1, 2, or 3, we just print oops, enter a valid input, please. So this is basically conditionals in ARM assembly, and in the next video we're going to cover iteration, which is actually going to be the last video in our Intro to ARM assembly series.